Assalamualaikum. Hello everyone, my name is Ahmad Rahim and today I will be presenting about the topic of asynchronous counter. Asynchronous counter is a type of counter in which only the first flip-flop receives the external clock signal, while remaining flip-flops are triggered by the output of the previous flip-flops as the clock signal passes through the flip-flops one by one. This delay that occurs is known as propagation delay. Asynchronous counters are simple in design but operate at a much slower pace. The main difference between an asynchronous counter and a synchronous counter, which are by the way different circuits altogether, is by the way the clock signal is applied. An asynchronous counter uses a ripple clocking method, while a synchronous counter uses a common clock for the flip-flops. The IC7476 is used to build the asynchronous counter. It is a dual J-key flip-flop IC. The J and K input logic are set to high on every pin of the IC so that the flip-flop works in toggle mode. The clock signal is connected only to the first flip-flop. The output of one flip-flop is connected to the input of the next flip-flop. This creates a ripple counting effect. The clear pin is used to reset the counter to 0. The output is connected to the LEDs on the red digital trainer. The counter starts at 0000, which represents the decimal number 0. Each clock pulse increases the count by 1. The LEDs show the binary counting sequence from 0000 to 1111, which is from the decimal number 0 to decimal number 15. After reaching 15, the counter will subsequently return to 0. Now we can see that the outputs of the LEDs correspond directly to our intention, which it starts from 0000 and finally to 1111 before subsequently return to 0000. Here is an example from another build.
Assalamualaikum warahmatullahi wabarakatuh. So today I want to explain about the sync counter. So the synchronous counter is a type of counter which all flip-flops uses the clock signal at the same time, since all the flip-flops changes their state simultaneously. There is no ripple effect or propagation delay. So synchronous counter is faster, more accurate, and more suitable for high speed digital application, although the circuit design is more look like a more complex. The IC, which is the 7476, is also used to construct the synchronized counter, and in this configuration of flip-flops has the same clock signal simulation. That is, the J and K inputs of each flip-flops are connected using logic gates, which in our circuit uses an AND gate, AND gate, so that each flip-flops toggles at the same correct time. So I want to explain about the synchronous counter. The circuit start counting from 000, which represents the decimal number 0. As the clock pulse apply the LED display the binary counting in increasing order. The counter is designed to stop at 100, which represents the decimal number of 4. When this count has reached the reset logic is activated to clear the counter back to 00.
The LED's output clearly shows the counting process from 0 to 4 before repeating the circle. The LED's output clearly shows the counting process from 0 to 4 before repeating the cycle.
So what we can conclude is the IC that I just told you about, the 7476, it can be used to implement both a synchronized and synchronous counter. And we can see that the synchronized counter is simpler but slower due to ripple delay, while the synchronized counter is faster and more reliable. That's it. Thank you.